Viewers, let us resume. In the previous video we managed to get the Cuda files to build and build easily, and now we'll be able to do some more. I'm just wondering about one thing. What if I put in console integrated terminal here? What would that... property console is not allowed. Okay, that takes care of that. So okay, we can launch the kernels, and I realized that because of the changes to the various code generators, pretty much all the tests are incorrect now, but I'm not going to bother fixing them right at this point. Instead, what exactly do I want to do here? Like, okay, we can run the things, and if you remember two videos ago, we had issues with cluster dimensions, and now this kernel runs properly, and that's because we are actually setting the max potential cluster size like this. So that's cool. So let's go back to working on the Leduc game. So we have the base, we have the card, we have this function here, and in fact now that we have that we're going to be using the C++ backend, it's going to work if we use the stack mutable type, and that's going to be a lot more efficient. Stack mute. Oops. Like this. I'm just wondering, do we even have the stack type? No, we don't. And we only have the stack mutable. Okay, I guess that makes sense. And in compile code, these stack mutable types will get passed around as references. So let me think. Let me comment this out. We don't need to import the random because that's Python code. We have to create the deck. I mean, getting the bit count like this won't work anymore. What we want to do is test the find and set bit. And we're converting the mask to an I32. I mean, why not? Let's give it a try. I think this should work, unless there's a bug somewhere. And there is. Yeah, we need to return 0 I32 from the main. Really? Oh wait, we have two mains. Sorry about that. Build. Deck Cuda. So yeah, here we have the stack mutable type, and it's gonna come. It comes out like this. And the C++ compiler will optimize all of these integer and boolean statements very well, unlike Python. So it's going to be this implementation is going to be pretty fast. So it's getting the stack mutable, and it's getting that as a reference, so that won't really... I mean, it won't even matter if it wasn't a reference, but it's going to be done efficiently either way. Okay, let's try building this and running it with Ctrl-Shift-B. And it's not working. Why is it not working? Yeah. What exactly is the mask? Let's print it out. Build the file. What it should be? It's 58. Mask bits and sequence count. It's sequence offset. Function base plus up. Excuse me. Okay, I'm back. So I put in some print statements and let's see what happens when we try running this. Okay, so 58 got a hit at index 1, 3, 4, 5. Yeah, that all makes sense. So what exactly is the problem? Um, yeah, let's print out the C. C, offset, offset. Build, we. Okay, so it gets a hit at index 1, C is 0, offset is 0. Got a hit at index 3, C is 1, offset is 0. Got a hit at index 4, C 2, offset 0. Okay, so like when it gets the first hit, why is it not going into this then branch? It's C0, offset is 0. Let's take a look at the generated code. If 17 equals 2, okay, I mean, is this not right? Hmm. Well, let's print out the conditional. Yield, Ctrl Shift V. C equals offset false. Okay, why is this false? I mean, this is Oh, so this is a reference. This is where it gets referenced, and it gets referenced. Crap. Yeah, I vaguely remember this was actually done on purpose, but I can't remember what the reason for this was. I mean, obviously it wasn't a good reason. I got to go over videos on Spiral when we were implementing the stack mutable type. In order to figure this out, I guess it made something easier. But obviously these semantics in the compiler aren't correct. So basically we get this v17. Then we actually increment the original value, but because it's a reference and not a value type. Oh, sorry, people are coming into my room, so let me disable the camera. As I said, I had time to think about it, and I think the referencing stack mutable type needs to result in a regular value type. I don't see any other way but to do this if we want to fix this issue. So yeah, that means that's probably going to break a bunch of stuff in the previous version, but who cares? The Cuda generates a reference type in the compile code. But damn it, why did I do this? Reference. I think I even put something in the readme for that. Stack mutable layout types, new layout type. Much like for the other value, for the other layout types, indexing to them returns references. Oh, really? Okay, I have no idea why the hell I decided on this sort of design. Whatever, let's check out how it's implemented. We're probably going to change this. I can go here, here, and then in the Cuda codegen, where is it? Codegen CPP, okay. And layout index. Layout index by key. Yeah, I mean, to fix this, all we have to do is just remove this. And then they will be generated as regular types. I have no idea why I did this previously. I think I did it for efficiency. Suppose we had a regular heap type. Maybe like this. I think in this case, maybe returning a reference type would be fine because they'd be immutable either way. But for heap mutable types, yeah, I mean the referencing now returns a reference, which kind of leads to all kinds of confusion. I mean, if you had some kind of different layout index that specifically returns a reference that is specifically intentionally returns a reference, Maybe that could work too, but this is kind of not exactly the best thing I ever designed in the language. But this is a pretty new backend, so it cannot be helped. Keep mutable, stack mutable types. Okay, so I guess we'll just publish it as a. Okay, no, we cannot publish it right away. Let's instead build the thing. Let's see. How do I build the thing actually? I mean, didn't I have a script somewhere? Oh yeah, this is the script to actually build it locally. .NET publish. Oh, okay. So PowerShell. It usually takes about 12 seconds. Okay, that took 14. I guess it needed some time to warm up. And okay, this we can close. What we'll do is going to VS Code plugin. We have a new version of Spiral locally, and what we'll do is run one of the tasks. And that task, I mean, not the task, but the launch configuration. Extension development with path, workspace folder, user home, spirals, ML library. Yeah, that will do what we want. Out files, npm esbuild. Okay, let us resume. Now my room is free. So we built a new version of Spiral. Now we just have to run this. Let's see, I think with F5 or maybe even Control F5. And as you can see, it says development extension development host. And that will run the latest version of Spiral. So let's try build. Now as you can see, this is not a reference type anymore. In fact, I don't even want the heap mutables to be reference types. Let's see. This was kind of a smart thing to do, but I mean, it's possible to work around it. We can kind of use the functions in the loop module and then kind of do regular types. Just duplicate them and then mutate them using. That's not really how would I put it? That's not really what should be idiomatic behavior. If he has stack mutable types and dereference them, we should get what we expect. Let's actually publish this again, and then I'm going to close the extension host. It all does take a while to compile now, it seems. Who knows, maybe it's because the recording is running, but I doubt it. As the language gets bigger, it's gonna start taking more and more to compile. So, okay, let's try building it again. Build file. I mean, nothing will change here. Let's Ctrl-Shift-V. Now C equals offset is true. Yeah, this is good behavior. It should be, if using a mutable variable results in one thing in one backend, it should result in the same thing in all backends. So I don't exactly remember why I implemented the reference indexing behavior, but let's change it. It's going to be what? This is 9th, 26th. The referencing layout types doesn't 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 generate reference types in the CPP backend. In the CPP backends. I'm also going to change this in the README. Layout types. Wait, what? As layout types in the Cuda backend would be pretty useless without this capability. Why would they be useless? Uh, Layout types in Cuda backend would be pretty useless without this capability. It has been implemented in Spiral v2.15.0. It's a necessary step. I mean the indexing returning references has been It's necessary to keep in mind that when indexing to layer types, the references and not value types will generate it in the resulting output. That when you mutate the values on the stack, we end up mutating in the layout type itself, even if they are intended to be immutable heap types. Okay, why the hell did I design this like so? Heap. For something like a heap type, it would be fine, but why did I do it for the mutable types? Oh well, I have no idea. I have no idea. Stack mutable layout types. Okay, I have no idea why the layer types in the Cuda backend would be useless without this capability. In fact, I'm going to pause here and maybe go back in time and check out some of my old videos so I can figure out why I wrote this. I'll be back soon. Okay, you know what, never mind this. I cannot figure it out from the video why I decided to do it, but it did juggle my memory a little, and it's almost definitely returning the reference types for the sake of performance. So I think it would be maybe for the heap type, it would be fine to return a reference for the variables that are being dereferenced. But for the heap mutable and for the stack mutable, maybe we should just implement a special indexing type later if we really need to return references from them. I think I did it. I think I did it like I did because I had no other way of just indexing into these types and returning a reference. I should have maybe added some kind of boolean here, layout entire layout index all that specifies whether the indexing will be done by value or by reference, and we'll leave that work for another time. Yeah, let's do it like this. I mean, who cares? It's not like the efficiency gains really mattered. The way I remembered it, we did manage to speed it up using stack types. I mean, using stack mutable types, but then we just removed those stack mutable types altogether, and it got even faster. So it was shit. Let me publish it again. I forgot where exactly. I mean, I didn't forget. We don't want the reference type being generated for the stack types. I mean, for the heap types. Now let's run it with Control F5. I got that Tau City job really did damage my brain. I cannot remember anything about my own code base anymore. I put so much into that work, and it's like it overwrote parts of my memory. I mean, that job was very good for the first couple of months, but the last few months were absolute garbage. And I'm glad to be out of the company. The only thing that I do regret is how highly paid the job was. I think I was making something like 190 grand a year. And it will be very difficult to find another fully remote job that pays that much, unless I get in at a large company like Nvidia. And good luck with that. You know, I can barely get anybody to reply to my applications, let alone get a highly paid job. So that job at our city was kind of like winning the lottery. Still, I did have enough of it by the time it ended. Okay, let's think. Let's compile this again. Then Ctrl Shift B. It actually isn't that bad that I forgot a lot because that will kind of put me at a different starting point, and maybe this time I will be able to make progress. So yeah, it returns 1 when we run this. Now let's get rid of the print statements. Let's try finding the end set bit at position. I mean at offset 1. That's like the second end set bit. Whoops, sorry about that. I forgot to build this. And then if I press Ctrl Shift B, okay, so there's a fatal error, and then it executes the follow-up task. I don't think that should be happening. Your tasks, Cuda program. I mean, it depends on it, and the task fails. So why is it executing it? Okay, let's ask Perplexity about that. Why is VS Code executing a downstream move task if the one it depends on failed? Actually, I didn't expect this kind of response. I thought maybe that the PowerShell script simply isn't returning the failure correctly. But yeah, how this. Okay, so let's build this. Let's Control Shift B. Sequence offset. It seems I forgot to remove this print statement. So yeah, it manages to find a set bit on the third index. So in binary, it would be something like 111010. And this is the 0 index. This is the 1 index. This is the 2 index. And this is the third index. And this bit at the third index is the second set bit. So that's why we see it at 3 here. Okay, that's not bad. Okay, so that's not bad. The only thing that I'm really wondering is whether this matches the behavior of the FNS intrinsic on the Cuda side. So let's do a Cuda kernel launch. We're just going to copy paste this, whatever. Open. Let's just open core Cuda. Open core Cuda. Let's remove this random. And what we'll do is try out the FNS intrinsic. And we can even actually pass the mask into the kernel. Wait, let's leave the right element in here. And intrinsic FNS. Let me just close this. I usually press Ctrl Shift S to save all the files. So let's check out in the intrinsic module. Where is it? It's somewhere in Cuda. Intrinsic. Oh, here it is. So it's just called FNS. Okay, FNS. Mask is U32, base is U32, offset is I32. Okay, so we don't even need to convert the mask. It's U32 by default. And let's try building this and running it. And what was it? Control K, Shift Enter, I think, to pin this. Oh yeah, and that. Excuse me. I'm sorry for the sudden cut off, everyone. My accountant called me on the mobile phone, and we spent nearly an hour talking, and then I went to have breakfast. But now we can resume. So yeah, what I wanted to test is the FNS function. I want to see whether it's the same as the find and set bit. If let's build it now, Ctrl Shift B, and what will happen? So this is 3, this is 1. Mhm. So maybe it is like this. Oops, not like that. But, and let's try this. Wait, why did it run twice? Executing task, build only. I'm confused. What the hell is going on? So the build script is also seems to be running the program now. Why is that happening? Um, yeah, it's only supposed to run it if the build only is false. Let's try it again. In fact, if you go into tasks, yeah, instead of running the Cuda program, we could just remove this build only suffix. Like, there's no need to run two tasks in a sequence. And this way, it also won't need to run the program unless it has already been unless it has been compiled successfully. Run. Current workspace directory. Yeah, I guess the current workspace directory needing to be changed is the only thing. Okay, but yeah, we can just change that in the build script. Let's see. We can just do cd and then what? Path binary. Set patient path binary. We can just leave this like so. Okay, let's try it out. It's compiling. And if I press Ctrl Shift B again, yeah, it's running the thing. Let's leave a little print statement. Running. wonder why there is this empty space here. I mean, I don't think I'm printing anything. Yeah, it's fine. Suppose I did something like this, like ASDF, and I pressed. Actually, no. Let's suppose I went into package, speed project, and yeah, it's saying that it doesn't know what to do with this. In VCC fatal, and it didn't run the command. And suppose I did this, like if I introduce some kind of error on purpose, and then Ctrl Shift V. Yeah, now it won't attempt to run the existing file. Yeah, good. Okay, this is great. So now we've fixed everything. In the end set bit. And now, yeah, now this is exactly as the FNS command. But the FNS command also has different types: U32, U32, I32. Okay. And the return type is supposed to be U32. Okay. So I guess we'll just convert this an integer, the solution, limit max. And I is the base. Okay, no problem. We just need a tiny conversion here and there, and now it's fixed. Actually, I don't even need the parentheses around this. Hmm. I just realized that another way of implementing this would be to, for example, just to shift the masked bits to the right, then end it with 1, and so whether it's not equal 0. I can just test if it is 1. I think that this would pretty much be the equivalent, but it's I think it uses a less intermediaries. This is better since it's not testing for 1 specifically. So I think the compiler will be able to maybe better optimize this form. But okay, well, let's build that. Let's test it. Same as before. Let's set the offset to something inner offset. Inner offset equals 2. Can be. I'm actually not sure what the operator precedence for this is. Like, could I possibly remove some of these? Basically, when it comes to operator precedence, I know the plus and minus are less than uh, multiplication and division, and I know that arithmetic operations are also higher on the precedent chains than the comparisons. So, but could I do it like this? I'm not sure what the operator precedence for shift operations is. Yeah, I guess this is fine. But I'm going to just put in parentheses here, just to be sure. We can be sure that it's not like this because we get an error. So we don't need a parentheses like this. But I'm going to include this inner one just for clarity, because who really knows what the operator precedence for this operator and this operator is? Like, I created the language and I myself don't know. Okay, so this is fine. Yeah, so we have our stack mutables, and yeah, how I put it in the changelog? Yeah, the referencing layout type doesn't generate reference type in the CPP backends. And also, did I change the README stack mutable layout types? Yeah, SLI types in backend would be producers without this capability. Maybe later we'll put in special indexing operations so that they actually result in reference types. But for now, I don't need this. Stack mutable. So it says that they cannot be returned from join points and conditionals. I mean, uh, like, would we actually get a compilation error if we tried doing that? I'm not sure. Yeah, I'm going to release this new version on the VS Code marketplace. Let's see. Um, ready to release a new release. But first, let's push it out. Extension development host. This is Spiral language. Where is the plugin? This is the VS Code plugin. Why do I have it open here? Probably because I opened it through the source control. Okay, so now we'll hit this publish script. I really love how much easier PowerShell makes this. The main thing I took away from the City job is how to use Docker, Kubernetes, and how to do shell scripting, and also how to work in Windows subspace for Linux. Mind you, I just picked all of that myself because I thought it would be useful for the job. Pretty much nobody at the job taught me any of it. So that's how it was at that startup. Okay, PowerShell publish PS1. Wait, I need to also pass in the pre-release flag. Pre-release. Publishing on EST. So I'm surprised that I don't have this package installed already. Okay, thankfully, it worked out seamlessly. Yeah, we're going to have to wait until it finish, until it gets uploaded. And in the meantime, we 27. No, it's actually 217 one. Yeah, is it not? Yeah, I shouldn't have closed it, but never mind that. Let's open the VS Code plugin again. Then we just press Ctrl F5. Now we're back in the extension host. Okay, find the and set width FNS. Okay, that worked. Now we actually have to figure out how to draw the cards. In fact, this whole thing, I kind of got sidetracked. It's good that I took the time to resolve the stack mutable reference issue, but I really meant to search for like a intrinsic instruction like the one Cuda has in order to deal with this. So, is there instruction equivalent to Cuda? It's not the fine grained floating point control. It probably fucked something up. Cuda FNS. It's an integer intrinsic. Yeah, let me try restarting this. Do I restart it? Oh, I didn't actually know I could select from different types. Guess the default model is sonar. Okay, let's try. For fuck's sake. Yeah, let me just copy this thing. I'm going to try Bing this time around. I mean, how is it possible that all of these are making the same mistake? Think deeper. Floating point nearest. Find first set bit intrinsic. Okay, it got it right. But I'm wondering, since I'm doing all my development work in Windows Subspace for Linux, what compiler is NVCC using on the host? I'm wondering, since I am doing the compiler is NVCC using NVCC in verbose mode. Hmm? So it's possible to also override it. Okay, I'm just wondering, is it really, for example, necessary to keep the GCC version up to date? Okay, let's go into the build. I actually never ever tried looking into this kind of thing. I mean, looking into what compiler GCC is using. I read in the Cuda manual that it's actually using something like it's using the host compiler. Okay, so this is the verbose compiling targets Cuda includes the GCC Cuda FE++ GCC I mean, what exactly am I looking at here? So these are probably all the commands it's sending to GCC. You know, let me just copy paste this into. Sure, now we should be able to see this better. Definitely, so it's definitely using GCC. So it's removing this fat bin. So it's actually invoking GCC several times. I'm kind of wondering what exactly is the difference between GCC and G++? Yeah, I guess it doesn't really matter. It's good enough that it works. I do like working in Windows Subspace on Linux because it's kind of like kind of like working in a container, and Visual Studio Code makes it very easy to work in it. You know, now that I recall, when I was starting the City job, I was wondering whether it would be possible to do language development in Visual Studio Code, and it turned out to be very easy. Like I only had to like clone Spiral in my VSL distribution, and then I could just do my development there as usual. The same goes for running the extension host in Visual Studio for Linux. Okay, has this thing. Just a second. Okay, let's close it a bit. But now we should have finished uploading the latest version. New release. No, it hasn't. This is version 271. Why isn't it updating? It's at least 926. Let me try restarting. How do I install a specific version? Okay, and now it should have switched. Reload window. Okay, so which one of these is valid? Oh, so actually it's bound to multiple ports. So is this? No, it isn't. Okay, I shouldn't have reloaded the window. Okay, maybe at some point I should really take some time and work on some things in the language, like support for commits, and to make sure that it's not loading multiple language servers at the same time. Okay, so, but yeah, this is basically a solved problem. The only thing I'll change is let's do a backend switch. Backend switch. This is going to be Cuda host, I think, and Cuda device calls fun. I'm actually not even sure if it's supposed to be like this, but okay. Core Cuda intrinsic, oops, intrinsic and FNS and mask base offset. And of course, this is the wrong backend switch. It only has CUDA device and Python. I need the backend switch with the CUDA device and CUDA host. So I'm going to have to take a look at the core library, backend switch, Python, CUDA host, backend switch. Yeah, I don't know if there was a better way to do this. Python CUDA. Okay, I'm going to change some things. I'm going to do a complete search over all the files. And this backend switch, I'm going to replace with backend switch all. This is going to be backend switch Cuda. I wish I could just use backend switch, the regular one for this. And in fact, no, this will also overwrite this. Oh, crap. I wish I could just overwrite this with backend switch Python. Okay, okay, let's do it like this. Oops. Yeah, I also need to make it. We're going to make this match case, match whole word. We're going to replace this with backend switch Python. Okay, so now this is messed up. I'm going to replace this with the backend switch real. Okay, I don't really need to do it. Let's just calculate in the core library. It's kind of renaming is a bit trickier in this file. I mean, in Spiral than it is in F sharp. This is going to what's even the point of passing a type here? I mean, it's not really checking for it. Most likely this renaming will broken quite a lot of stuff. Let's do a search for backend switch Python to see whether something whether I messed something up. The host, the device. Why is it causing trouble? Yeah, Python host. Let's also get rid of Python from here. Now, let's do a search for backend switch Python so I can see. For fuck's sake, oh yeah, this is going to be a nightmare. Yeah, because the backend switch also appears in types. So I got to turn that back into a regular backend switch. Replace Control Shift 1. To basically replace it when it shows up in nominals. Xoshiro does not need the type. Yeah, this does waste a lot of time, but it's also fun. You can switch. What the fuck? Yeah, this would have been a lot easier had I not been doing so much overloading. Let's switch Python. Okay, but we do have a hint. Instead of doing this, let's do a search for backend switch Python that's followed by a grave. So yeah, now we have this, and then we just replace that with backend switch real. Just a review. I'm probably going to get rid of all of this Python stuff since it's no longer useful. It's really amazing how quickly this code has become rotten. This is fine. This is wrong. It's a good thing that I'm checking. Keep putting it okay. Xoshiro. So switch on. See to the right. Maybe okay. I'm not actually sure how to do that. How to do it on the host. So Cuda single thread right. Hmm. Yeah, maybe I could just do this. We can switch on, then Cuda host, then console Cuda just right. Or actually, maybe it could be just yeah. So it's probably like this. Okay, that's one extension to the standard library. And switch on. Yeah, I probably missed it while I was doing this at work. Utils. I mean, that was commented out. Switch Python. This is shift and left. I mean, okay, that's fine. Okay, I think right now the problem is that, yeah, this probably crashed the Spiral server. And that generally happens when the editor tries to give it some file data that's not a part of the actual file. Like when you're looking in git commits and when you're doing editing, it doesn't support those features yet. Maybe at some point I'll just sit down and try to figure out how to make it work. But it's never been a priority for me. What has always been a priority is building machine learning libraries, trying out new algorithms, and so on. What does the camera look like? Okay. Extended library with a new backend switch. Renamed the old ones. And the previous design was fine when I only had Python and its CUDA backend, but now we have various different backends which interact. So the best thing to do here is maybe to just restart spiral start server. So yeah, when you do start server, it will it will close the old server and start a new one. Okay, that's the easiest way. And now find and set bit will work on both on device and on host. Okay, so the next thing that we have to do is the population count, and I think we should be able to do this on both the host and the device. Okay, oh, let's see, and that takes in what's this d? Yeah, that's just an unsigned integer. 32. Let's do this back and switch Cuda host. Okay, not this. Fail with to do. It's going to be intrinsic. Now let me open core Cuda here, so we don't have to keep opening it explicitly. And let's see, pop count. Okay, this is fine, but we also need to figure out how to actually do this population count instruction on the post. So how do we do that? What is the how do I use it? Let's see. This device, the host. Built-in pop count. This is a clang. As we see, wait, I mean, so it's supposed to take in an input. Could okay, show you an example. Let's see, unsigned integer with a malloc. Okay, how is it on the host? Where is it used on the host? Let me just copy paste. Let's do a macro. It's supposed to return on I32. I mean, it's not like this is a problem. So we have the pop count. Now we need the sample masked bit U32. How do we do that? And where is this function located? Okay, so it's in random. To do, make sure this does not cause warp divergence. Scan offset. Count. Now let me copy paste this into the deck file. We can replace this with the FNS that we created ourselves. And set width. Okay, that's one thing that we have made sure that it's polymorphic on both platforms. Make sure this doesn't cause more divergence. I mean, if we want to make sure that this does not cause more divergence, we could just do a warp synchronize at the end. Okay, that makes sense. I'm just thinking how I could ensure that it does not cause warp divergence. Let me pause for a bit. Well, let's deal with this. We're just going to replace this with popc. I mean, let's just make it popc u32. u32. It's the population count. That's for this. Okay, over here it's impossible for there to be a warp divergence, like because the DL's case here we just abort the entire kernel, and over here it's possible. You know, but what we'll do is backend switch Cuda. In fact, let me just copy paste this whole thing. And on Cuda host, we don't have to do anything. For device, we just need to do a warp synchronize, warp sync. And I don't know what the intrinsic for that is. So let me look in the Cuda core library. Core Cuda, is it in base? Warp sync. So it's a sync warp. And there's also sync threads. No problem. Oh, that takes care of that. Here. Side. But you know, is the warp divergence even that much of a problem? I don't know. I mean, so what if there is a warp divergence? Is that something we need to usually care about? Hmm. We, I mean, let me pause a bit so so I can think about what my principles should be. Like, even if there's this word divergence, so what? Yeah, who cares? I won't even pose sample last bit. Let's make this template. Let's make it list U32. Easy. So we have quite a lot of stuff. And the main thing that we are missing is this U32 bound, and that's from the random module. It generates a random U32 integer within a certain range. Um, yeah, we did spend some time implementing it, didn't we? Yeah, we need to make it like this so we can actually sample random integers on the GPU. We run into issues. I think, yeah, Cuda does have a bunch of random number generators, but it doesn't have anything to sample in a range. So we had to create this. And thankfully, tail recursive loops do work on the GPU most of the time. Model version, divine sampler. I think I'm kind of doing some kind of rejection sampling thing. Pretty much I forgot why it needs to be like this. If if it's a range, if this is a literal, then it does this. Otherwise, it does this thing here. Okay, it's an interesting implementation. I completely forgot the reasoning behind it at this point, and the only way to remind myself would be to watch the old videos that I created, but it's not that important. So, okay, so we have this skip ahead. What the hell is skip ahead? Oh yeah, it skips ahead in the random number generator, and yeah, that's completely unimportant. Uniform normal, log normal, Poisson. But you know, we do have these prototypes, so if we wanted to, we could probably try to implement the same interface on the host. Here we have these reference types. Let me just take a look at the base. Let's see, ref. Yeah, here we have this. We have the reference type. But right now, instead of using this reference type, we could probably just use a stack mutable type. What would happen if we try doing that? Also, let me. Yeah, there are no problems here right now. Suppose we did type ref t stack mute t. Yeah, the problem is that the the layer types aren't actually are kind of types in the usual sense. So the type inference for them doesn't work. It only really works like this for nominals. If we instead did this like nominal, yeah, now all the problems go away. And I think we have an entire module dedicated to reference types. Set ref copies the reference value and stack mesh address. So these are duplicates. Set ref. Will this still work? Maybe it would be better to just replace all of this with the stack mutable types. To local from local ref index. Maybe if we did that like let's see stack mutable L, that won't work. Interesting. Yeah, the stack mutable takes in a reference. Yeah, this actually won't work. These reference types are different from stack mutables. I guess it won't. Let's do it like this and be done with it. Like the reason why I decided to go to not to just use the regular macro types is because the macro types won't require any extra code generation. Like even if you do a stack mutable on something like a single integer, it still needs to generate a stack mutable type in the resulting code. Well, this thing just results in a straight up reference. I mean, this reference type. So I guess there's no choice but to do it like this. So yeah, this is actually copying the value. Stack mutable types are different. I guess everything has its place. Okay, so what was I doing? The random sampling. Yeah, I need to figure out how to do the. I need to copy the entire thing. What the hell did I do? Okay, so we need this. We have all of these prototypes. Can we actually somehow implement this using the default C++ random number generators? Okay, tell me about the C++ random number generators. Let's call the basic quality. This was yeah. It's kind of. I remember doing. I remember playing with this while we were doing the FPGA videos, and it's kind of annoying to do it like this because we're gonna need the random device, then we need the whatever the engine. I have no idea why we need both the device and the engine. Then we have to make an integer distribution. Right. So we need to pass the engine into the distribution. How exactly will we deal with this? Okay, I guess we can consider this as like a single thing. I could kind of put in. Then what exactly do we do about the distributions? Like, do we just whip out the distribution whenever we need it? Yeah, I mean, if you don't think about it, this isn't that bad of a way of doing it. What's this? What is this empty template argument? I'm kind of confused about that. Oh, it was also empty here. I guess maybe it has some default template arguments. Okay, also we can ignore this. Okay, but what about what the hell is this question? The device. Really? It's modern fast with excellent statistical properties. Here it says it's excellent, and here it says it's very good. And excellent is better than very good. It's much faster than Emerson Twister for proceeding, small return state, not part of the standard library. Really, it isn't part of the standard library. Yeah, I mean, we are literally doing multicolor simulations, so I guess we should use this. Okay, where do I find the Xoshiro? I mean, what's this random device? Can I use the... What is random device? Can I use the engines without it? What the hell? Uniform distributed of its range. So this random device is actually like just giving the seed to the other random number generators. Oh, okay. I guess that makes sense. Yeah, where do I get this Xoshiro? Where do I get this? Xoshiro? Single header file, single plus implementation, the quick following Xoshiro. It's today. Let's see. Where the hell is this used? Is it I mean, I think these are the lambda arguments. Oh no, wait, they are references. So these are the captures inside the lambda. But it's so complicated to do this with C++. Like, it's kind of annoying that you have to specify, how the capturing is done. It's much better to just specify whether a type is a reference or something else directly on the type itself. Okay, so XCCO, degen. But I think this code is actually wrong. I mean, this distribution should probably be this D. This is the histogram. Okay, so stud map. Yeah, it's great that I think this is a mutable dictionary. So C++ is calling them maps. Random int, print that histogram. I kind of like this C++ code because it does feel very modern. Like it's using lambdas. It has this for auto. Okay, this auto, I think it's the type, so it automatically infers the type. And this bucket count, okay, what the hell is that? I think it's probably destructuring this histogram. So it's probably iterating over the histogram. Then this bucket is the key. This is the value. I've actually never ever used this kind of for loop in C++. Auto n, static cast, stud size t, count divided by 100, stud set v. Okay, I have no idea what set v is supposed to be. Maybe, oh yeah, it's probably set width, but with the width for what? I guess it's kind of, it pads the integers if they are smaller than 2. I mean, it pads the integers maybe with empty spaces, so they are size 2. String, stud string. I set type alias. That's freaking damn it. I hate CMakes so damn much. It's so complicated to use. It's actually easier for me to just make my own script to clone this repo. Okay, let's do it. So it only has like 10 commits. This is a pretty recent library. Okay, so let's copy the full SHA. And I'll show you maybe how to do this in a script. Compile Catalyst example, no, not this. Install CPP dependencies. Yeah, I wrote this PowerShell script, so it clones the Thunder Kittens CDs into it, and then there's a git checkout. So I guess we'll be just let's do this. Install Xoshiro. ES1. This is the SHA. Let's copy paste all this. I mean, we don't need to copy paste all this. I just wanted this. I guess we'll be using this directory cpp libs. It has so it already has Cutlass and Thunder Kittens. Okay, not bad. I guess we might as well put it there. Install Xoshiro. Yeah, I guess it we can cd into that directory if it doesn't exist. Installing Xoshiro. Um, can I do a git clone for a specific commit? Do I do a git clone for a specific commit? And incidentally, I never really got the chance to look into the tender kittens library. I really wanted to do it, but god damn it, work got in my way. Just, one of the regrets from this job is I actually got hired when I applied to it on a pretty much random post on the Cuda subreddit. And I thought, they're looking for a guy who knows how to program GPUs. I never once got the chance to program the GPUs. Instead, I came in, and what they were using to host LLMs was a Flask server with a script that probably just ran the model in PyTorch, so something pretty stupid like that. And I did some research and replaced that with VLM, and that was my first contribution to the company. I mean, it's not like that. Like I even knew what to do for that particular job. I was just good at doing research, and the coworker who implemented that first version isn't good at research at all. Git clone repository URL. I mean, clone depth. For fuck's sake, git checkout. I'm gonna do a git clone. Can I do a git clone for a specific commit? Yes, the specific commit. So this is the Xoshiro. Whatever. Um, Xoshiro. This is 9, oops, 9/26, 2025. And I guess this would be 16 for 2025. I'm going to adjust this a little. Of course, doing this kind of has issues with updating the dependencies. Yeah, now that I think about it, these package install scripts do need a bit more work. Like, okay, so cloning the GitHub repo for a header-only library is a good first step, but it's not really the only step. But if the path exists and the Git repo is already there, fuck, it's testing from the wrong folder to begin with. you know. I mean, yeah, I suppose it could be, resolved by eliminating a little bit of CMake. But as I said, I dislike CMake because it's kind of like a fully fledged scripting language, and you should see how they use it in Catalyst. It's pretty much a nightmare to deal with. It's just like a thousand imperative statements all at once. That's not really how package management should be done. And C++ does have a package manager. I mean, I look into it. It has something called Conan. It has something else. But then they're also pretty complicated. So what exactly am I supposed to do here? Um, yeah, it's actually a good idea to really to maybe just slow down a little and maybe decide how we really want to do package management in C++. How do we do package management in C++? How do I do package management in C++? Yeah. I look into this VC picking key in Conan. Let's see. Yeah, I mean, CMake can also build CUDA programs, but when I tried actually, I once tried using CMake to compile CUDA programs, and they ran into very weird errors, which I couldn't really figure out how to fix. But when you have a PowerShell script, you just called MECC, and that's about it. You understand everything that's going on. Um. Okay. Suppose suppose the goal is to do a git clone. All I have to do is just do a bit of git clones and maybe check out the latest commit. And whenever this is run, we also want to maybe update the repository. How could that be done? Okay. We're going to just use our own scripts. It's not really worth learning all of this. It's just going to add a shitload of complexity. Like, okay, this is one place when, if I was to be mentored by a more experienced C++ developer, and he told me that, yeah, I need to use this, okay, then I'd use it. But I did actually look into this, and it's really complicated compared to any other package manager. In .NET, you just, do a .NET add package, and it adds the package to the project file, and that's it. But over here, I think I ran into situations where maybe some packages don't even exist on the repository. So then you have to, try to figure out how exactly do I add a, random remote Git repository to the list of repositories and so on. Even Python is better than this. So yeah, I mean, what I'm going to teach you here isn't really the best practice, but I just don't know what the best practice is when it comes to package management in C++. Like, I would like to see maybe some package management tutorial that's like 10 minutes long and kind of covers everything that I need. I don't want to. I actually saw, like last year, I looked into CMake just because I wanted to understand how to compile Catalyst, and there was like a couple of hour long course on it. Somebody even wrote books on CMake, which just tells you how much complex it is. Let's say we are trying to use git clone for a package management. Can I use git clone to update local repo. Yeah, I kind of thought that it would say this. Okay, okay. This is let me do a more general function. Install git repo. We're going to do a param, and I think it's like URL, and this needs to be like yeah string. If this must not be now, if URL equals now, then raise row. For fuck's sake, how do I raise an error in PowerShell? How do I raise an error in PowerShell? No, not the right error. Terminating error. So it has a throw. No, this is just a standard .NET exception. The URL must not be now. Okay, that's one thing taken care of. Maybe it's actually even possible to set it in the parameter that it's a required parameter. Um, parameter required. So it's mandatory. So it's something like this. So the parameter must be mandatory. We'll cd into the library directory, and then we'll test the folder path. And first we have to get the folder, and we're going to get that from the URL. And the way that we're going to get it from the URL is we're probably going to just use the split path, and I think maybe leave a base, or okay, not the parent, the output. Yeah, but yeah, let's try the split path with base. Let's print this out. Like, we don't have the tender kittens. What the hell? We're just going to print out this, right? Host. Right host folder. Let's get rid of this. I mean, we don't even. Yeah, we also need the checkout. Okay, string. It's I think, can I just do git checkout latest, something like that? Git checkout latest. Git checkout head. How do I check out Git? How do I check out the? Do I check out the latest commit? Run. git checkout origin. So a simple way is to check out the branch itself. Um, so is the branch for Xoshiro main or master? So it's main, okay. Okay, we're just going to set this to like main. No problem. It's just going to be a default. So we don't have to do anything weird here. Okay, so okay, now let's try running this. Git install repo, and then I'm going to pass this in. Oops. Wait, this is supposed to be URL. Let's make it big. URL. This is supposed to be URL. Xoshiro. Okay, great. It worked. And this is now the folder name. Let's rename this to something like git there. Okay, now we can actually test for it. Like, if it doesn't exist, then just do a git clone. Otherwise, yeah, do a git clone, check it out, whatever. We don't need to cd into the git directory, then check it out. And, you can just make the commit, git checkout commit. We don't need anything here. Oh yeah, we also need, we should just also just put the URL here, clone it, cd into it, and then check it out. Else, instead of cloning it, we just cd into the git directory, do a git pull, check out the commit. In fact, in this last part, I mean, it's the same in either case, so we can kind of factor it out. Git checkout commit. Yeah, I don't want the checkout to be done if the other commands fail. So I guess that's that. I mean, you can do an end, and then if commit is not null, then we just yeah, if the commit is not null, if is null, not equal null, left side of the equality comparisons. I mean, I suppose this is fine. Suppose I do also if the last command worked, and I think this is how we do it here. If it's a dollar and then the question mark, that returns the status code of the last command. I guess that's one way to chain it. Yeah. Installing URL. Installing git repo from into. So wait, right info library directory C++ library directory is libdeal. So I also want to do the commit. And what we'll do later is just put these URLs and the commits into something like a record, and then put those records into an array, and then just iterate over them. Now let's test whether this works. PowerShell, install Xoshiro. Maybe I could just do a git switch. Suppose I git repo from. We're not currently in a branch. Oh crap! So it's an arbitrary commit. It doesn't pull it. Git pull remote branch. It's actually a problem to check out specific commits. Let me pause just for a bit. We have to do. If I wanted to go to main and then do a pull and then do a checkout, Yeah, it's as you can see, it kind of gets complicated to manage based on the GitHub repos. Right now, I'm kind of right now I'm thinking about how to do a pull and to do an update. And it's kind of complicated, isn't it? Um, I mean, maybe we should just get rid of the pull. I want to reserve the right to update the repo. We're doing the update. Yeah, I mean, if you want to do the updates, you kind of need the log files and. Uh, yeah, this is complicated. Okay, can I actually yeah, let's suppose the repo exists, but I come in and maybe I change the commit to something else. How would I actually change the repo? Um, mm, Let me check. Forty characters. I have selected these, and yeah, there are 40 characters. Okay. Let me check out the. Okay, what I'm going to do is simply. What's this? Oh, commit. I'm going to do this. With reverse parse head. Then if commit not equals old commit, then just like cd out of it. Cd lib there. Yeah, I don't like do it. Cd into the git directory. Then cd is out of it. Then pretty much git there. Then just clone it again. Then check out check out the commit. So we want to cd into the git directory, check out the commit, cd into the git directory. You don't want to check it out if it's not null. Oh, for fuck's sake. Okay, and now I'm pretty much implementing my own package manager. You know, maybe I'll just let me pause here. I'll do some research, and maybe I'll just come back when I can show you the finished product. I'll be back in a flash. Here is the finished product. I kind of touched it up, factored some things out. The most interesting finding about PowerShell that I discovered is that it can push and pop locations. So this would kind of enter the directory, and then if I want to undo that operation, I could just do a pop location, and that's better than writing something like cd, which is equivalent to set location in PowerShell. It can it starts complaining if you type cd and then it says that it's an alias of set location. So we have the get repo, and in get repo we do this. We compare it with the latest commit, and if it's not equal to the target commit, we just downgrade the repo. This bit here is so it suppresses the detach head warning. It's very annoying. We check whether the commands work. If they don't, we just throw an exception. If the commit is right, we just print out the latest branch matches the commit. Let's see. Wait. What if the commit is not there? Like okay. Let's do this. I actually haven't tested the case where the committee isn't there. Okay, the checkout failed. Empty string is not a valid path spec. If null not equals commit and when it comes to these operators in PowerShell, I'm not really sure what their precedence is or whether there is any precedence at all. So let me just wrap them in parentheses. Empty string is not really. Yeah, let me print out the commit here. Right, host commit. So I guess it's not a null, but maybe an empty string. Yeah, what if I do this now? Downgrading repo to commit. If not null not equals commit. Okay, let's just print the result of null not equals commit. Let's see what that results in. Okay, so that's true. How do we test if in PowerShell the string is null or empty? In a PowerShell, how do I test whether a string is null or empty. So yeah, I guess I didn't even have to test them out explicitly. I could have just done this, like if commit and commit equals. Let's do this. Well, this branch matches the commit. Okay, let's touch it up. If commit, then otherwise, yeah. I mean, we don't have to update it to anything. Let's see. What about removing? We have the get repo. If it has path, if now, okay, this we need to change. If commit, let's go commit. Okay, so let's do this. So you should probably hit this branch. Skipping update to no target commit ID. Or URL. Oh yeah, this is very nice. Yeah, imagine doing something like this in Bash. It would be horrible. I mean, you could also kind of do it in Python, but it would be. I mean, imagine trying to pop the locations, get the locations. I mean, push the locations, set the locations, and then execute these commands. Yeah, imagine trying to do this in Python, which people usually use Python for shell scripting. But when we see like a shell script like this, obviously PowerShell is far superior to Bash and Python. Like when I do this, I feel that I am actually programming. So yeah, this is kind of nice. Now let's put in a commit. Well, this is the latest commit. In fact, let's just remove the repo. So we see how it does. We're kind of hammering the GitHub server. Cloning. Nice, nice. Right, skip the update. If we try a different commit like this, and then run it, it will remove the entire repo and downgrade it. It is now at this. And if we try going into it again, it will skip it. But if we try going back to the previous commit, which is the latest commit as of the time of the recording, then it will remove the git repo, install it, and then try to check it out if it's not the latest. And if it's latest, it will just print out the latest branch, much as the commit this thing. And yeah, now in these repos, we can just put all the repos that we want, and it will download them into the cpp libs directory. Okay, so I think we have to do You have to take this thing and add it to the build script. Let's see. Build script. Okay, how do we do an include? In fact, let's go into Kotlin studies. I just want to use it as a reference for how the includes work. So yeah, it's just big I and then the directory name. Okay, let's put it like where? I guess at the very beginning, I and the directory name. cpp libs Xoshiro include. Is that how it was? Yeah, that's exactly how it was here. Oh yeah, and I forgot the backtick. The backtick is the same thing as the slash in bash scripts. The only thing it does better than bash is it warns you if you have a white space at the end. And this kind of tripped me up in bash sometimes while I was working at Tau City. So yeah, I really do appreciate what what Powershell has to offer. It does make shell scripting a lot easier. I mean, if you haven't tried it, I very much suggest that you do give it a chance. Like just for publishing the spiral language, this simple script. Let me open it again. I mean, this is like the simplest script ever, and it's very helpful. How about I do this? Try. Either way, we want it. If a publish doesn't work out, we do want to remove these files at the end. Maybe we could just do it on this try. Then finally, wait, and then where will I put these? That maybe I could somehow nest these, but no, that won't work. Okay, so okay, improve the publish script a little. Improve the publish script a little. And yeah, PowerShell does deserve a lot of praise. It's it's fantastic. Right, host rank release. Oh yeah, I think I left this in by accident. I should just remove that. Remove accident. Let me put these together for niceness. Okay, so we have the Xoshiro added to the list of includes. Now we could actually try compiling it, try compiling the program with it. And it should work because we know that NVIDIA just sends the host side to GCC. And Catalyst and Thunder Kittens, we should probably maybe update them, but I'll leave them like this for now. This should be not like this. Yeah, I should install CPP dependencies. And let me get rid of this. In fact, I should rename the. I should save the name, get rid of it, rename this to install CPP dependencies. The list of dependencies that need installing. File Catalyst example. Okay, so yeah, I don't need the Catalyst studies. I could have just looked in here. Copy static assets. And those are for the web UI. Whatever. We have the Catalyst study, so let's just get rid of this. We'll clean up this a little. NVCC help. We'll leave this in. Whatever. Let's leave it in. What's this script here? What's this script here? Yeah, this script is probably when I was demonstrating the Hopfield dictionary a couple of videos ago, before I took a year-long break from YouTubing to do paid work. Okay, need script install CPP dependencies. Okay, that actually I'm thinking, do I even need do I really need to just for every library to just jam it in like this? Instead, I could maybe just do inside the C++ file itself. I could just do Xoshiro include. No, let's do it like this. It's it will be ugly. Okay, so let's see. Okay, Xoshiro. Let's try an example. We need this include Xoshiro H. Okay. These are Kata studies. Okay, so deck M. We probably need another example. Let's make this test 0. Let's make another test. We'll make inline main equals test1. Now, how do we actually include that thing? Include Xoshiro H. So one way is to just put in a global like this. I wonder if we have an import. No, we don't. Okay, so this will have to do. Kind of forget what the difference in C++ is between these imports and the bigger imports. Whatever. Let's get rid of all of this. And let's start building this. Whoops, I didn't mean to restart the Spiral server. Let's build the file. Let's check it out. We have this, no we don't, build file. Sake, why is it building the file? Build the file. Oh, no, this isn't working. What the fuck? I mean, is there something wrong with the Spiral server? Maybe because we restarted it, it kind of ended up sending the messages to the wrong one. Maybe the connection simply broke. Yeah, the Spiral server has everything it needs, but it has some edge cases. It's kind of hard to restart it properly. Okay, let's build it again. And is something happening now? Yes, it is. Oh, thank fucking God. Okay. Now let's Ctrl-Shift-B. I want to see whether this actually builds. Okay, we didn't get any error. Suppose I did something like Xoshiro SDF. Obviously, this header file doesn't exist, so we should get an error during compilation. Yeah, we get an error during compilation, and this proves that this exists. Okay, not bad. So now we can actually try translating some of these examples in Spiral. So we need these XCO RNG. We type. Yeah, I'm going to actually create a separate module for this. Like, usually we'd want to put it maybe, I don't know where, maybe in a core library, but I don't want to do that right now. So let's just put it here, Xoshiro. We're going to go in here, nominal RNG, and it's going to be XCO RNG, and this is going to be the type. And this normal distribution is from include random. Okay, so that's we're going to do. We're going to put that in the test. I think I need to just. I'm going to at the top of every module that needs an include. I'm going to put in this include. So we need to open core base. I think, yeah. Let's Xoshiro include. I guess we'll just open Xoshiro here. They're making that include. Now, what do we need? Okay, so this is using a bunch of stuff. Wait, what is EO manip? Maybe it's kind of like an extended IO string. This repeats this character n number of times. It's divided by 100. Okay. What's this set with? If you look here, you'll see that this is 2 characters long. This is discuss on a white space. We already covered this. Okay, so it's kind of going to be annoying to translate all this to Spiral. It's actually much easier to do it in C++. I'm going to have to do something. So this can be actually, yeah, I noticed that this actually didn't pass in the random device. Instead, it initialized it just like this. Okay, that's very convenient, and it can probably somehow make it generate integers. Probably even unbounded ones. Okay, let's. I don't want to do in very intricate stuff. I just want to have it match the prototype for the Cuda. Init RNG. So we need to initialize it. Here's U32. So I think we need to figure out how to get that RNG to generate unbounded integers. And then all of this is pretty much, all of this can be done the same between the Cuda and the host backends. So we have these globals. Okay, instead of include, yeah, let me change this to globals. Then we need to initialize the RNG. I don't know how to do that. I mean, seed, subsequence, offset. Then we get the reference. Oh yeah. This doesn't create. This doesn't strictly create a new RNG. We just need this prototype function, and we need the U32 and yeah, we just need to implement this instance. Okay, let's go into Philox. I mean, into Xoshiro. We'll open core Cuda random, so we can import all the instances. Then let's just paste some of them in. When it comes to importing these globals, you cannot tend to put it everywhere. Okay, let's remove it from here. We don't need it unless we initialize it somewhere. It's kind of a bad habit, but it's kind of also annoying to have to keep doing the includes every time. Maybe I could just implement it as a language feature whenever the user does an open, then just run the globals. That could also backfire because the globals could be. I mean, the modules can be opened anywhere. So never mind that. So this is the init RNG. Oh, actually, I'm not even sure it's possible to initialize the RNG. But we actually don't even need to follow the same interface for initialization. You only really need to figure out how to get the unbounded integers. Okay, never mind this for a bit. Let's just copy paste this entire thing. Let's do this. And then what? Let's press Ctrl Shift B. Identifier, yeah, this. Yeah, I did mention earlier that this is probably a mistake. List. in the example. So let's build it again. Great, it worked. Uh, Now we don't actually need all this. I just need to figure out how to like generate the most basic integer. You just get single result type and prep for next call. How about bit count, index, max min, sample, seed, Xoshiro name, for fuck's sake. Okay, how do I get a single unbounded integer from like Xoshiro? I'm going to expert plus. How do I get a single unbounded unsigned integer from the Xoshiro energy? What the fuck? What the fuck? You know, what is it doing? Somehow, rewrite it somehow, rewrite this answer. Let me try Claude again. I only made a single query recently. Plans don't grow with you. Use Claude for free, whatever. So you just use the next method. Use rand. Well, I didn't know that it was actually included in Rust. And okay, C++. Oh my god. I'm using. Okay, so I need to. So I can just invoke it like this, I guess. Okay, let's get a try. And let's print out the value std count value. This. Wait, what did I do? I meant to press Ctrl Shift B. I can know, but I did press up and enter in the terminal. Okay, so these look like unsigned 32-bit integers. Okay, amazing. This was super easy. Okay, so let's go into deck M now. Actually, no, let's go into Xoshiro. Okay, we don't need this init energy. What we need is where is it? U32. We just need this is the Xoshiro energy S, and then we just need to invoke it, and that will give us what we want. Yeah, great. And now using this energy, we will be able to draw the cards. Yeah, perfect. I need to go for lunch, and I'll see you guys later. Bye bye. Let's resume the session from yesterday. I added a new news entry into the README, and for today's session, let's aim to finish the at least the deck module. We managed to get the Xoshiro random number generator done. Find NZ bit, find sample mask bit. Okay, so we have the Xoshiro. Okay, so what we need is to basically implement all of this, and I think we have enough. Let's see, U32, U bound, and that's in Cuda core. Random. We don't want to use an intrinsic function. Instead, we created this one. And then this also doesn't have a type error. So maybe we could move this somewhere else instead of having it be in the random in the core Cuda random module, since it does have close functionality, but actually that doesn't really matter too much. What really matters is that it runs. Okay, so in this test, let's what we'll do is simply try to create that Xoshiro random number generator. Let's see. We have this. So can we do something like how do we create it? Do we just use init? No, init doesn't create it. Young state. Okay, so how is this one created? That's the only thing that I'm really wondering. Log state init from consequence offset. So this is how it's created. It is with init. Let's see. So it just creates it like this. I see. Okay. Let's just create create and then equals and then what? Xoshiro RNG. And how are we going to do this? I mean, we're going to do this. Is it creating it here? Or is it waiting unit? So it's just like this. Okay. So that would be Xoshiro RNG. That needs to be a type. and then V, and that's basically it. And in fact, let's just return a reference. Let's open or Cuda. So yeah, now we have a reference to this RNG. Oh, okay, so let's start creating it. In fact, let's. How is it actually? Yeah, we need to call the globals. So it includes the import. So RNG Xoshiro create. And let's console write ln, and we're going to let's see u32 RNG. Let's open random. Or maybe let's just do this. Random u32. So, okay, so let's see whether that works. We'll print it like 3 times. Then we just have to build the file. Go here, Ctrl Shift B. No, this didn't work. Why didn't it work? Like, it should have included the globals when I called this, but that didn't happen for some reason. Why did it not happen? Okay, it wasn't because of this. Stand. Ah, yeah. Probably because, in fact, because I had opened random and that overwrote this globals statement. Let's try it again and build. Now it's included. What's this S? To put in. I forgot to spice in the variable. I have just started sneezing. Sorry. Let me just pause. This works. So we have the random number generation done. What we have to do is maybe test the draw cards. Let's see. Card deck. Deck. This returns a static array that has a specific number of cards. And the number of cards is determined statically by this dim dimension. Okay, so let's test it out. Cards 3 and then deck. Yeah, we also have to create the deck. Then we draw cards. Wait, this is obviously a card. And we'll just print out the cards. I think it should work. The print should work on a static array. It doesn't. We get a compile time here. Cannot find the backend Cuda host in the backend switch. Really? Wait, what? Switch Python. Sam sp. I probably don't have the static arrays implemented. Okay, I guess we'll take care of that right now. Let's see, some switch Python. Yes, we could just do backend switch all with a host. With a host. Yeah, this is simple enough. Static array create. I mean, it's if it's this on device, it's definitely also on the host. They're both just C++ code. So let's see. I can switch. We have anything else? No, we don't. Okay. Start again, and we get another error. Records in backend switch. Expected a record with the host field. Really? So this is specifically in draw cards, and I think we're just missing some. We're probably missing a trace somewhere. I mean, it's probably SA create that's causing trouble. Let's go to into SAM. Let's see, SA create the host. Okay, let's put a print static. So the now if we go into the Power server, it should print. Okay, so it's not SA create. Instead, it's probably in the loop somewhere. Okay, so let's pull this in. This is switch. Okay, which backend switch is it talking about? I mean, it cannot be any that's here or here. So let's see, in row cards. Is this maybe in right ln? It actually gets here. Is this possible? This is unbelievable. Like, it should just do this print static and then exit the compilation. Like, okay, is this error happening maybe at the code generation time? Yeah, I mean, it's possible. Okay, let's do a search. Code drain CPP. Okay, it's almost definitely the case that this is the error. I'm just yeah, we definitely have the Cuda backend set because we tried a simpler program earlier. Okay, you know what we'll do? Let's just go. Let's just try out the draw card function. The error is definitely in draw cards. We'll just let's try running this. Okay, this works. As I do this, this builds. Okay, let's try running it. Okay, I think I'm trying to use the trap function on the host. Okay, so that's a reason why the compiler is still in pre-release. Let's see, trap. Oops, trap. Sir, no, it's this thing here, and it's this thing here. Um, yeah, depending on the backend, we need something other than the trap. We need I think in the regular C++ backend, we need abort or maybe exit. Okay, I forgot. Hmm. Okay, I guess we'll be working on this for a bit. Let me put in a bookmark here. Bookmark here. Now I need to remind myself what. So do we have the codegen backend handler, whatever that is? Oh yeah, that's for handling nested backends. Partial eval result. Code environment. Backend type. Okay, backend name. Okay, what's this thing? Backend type to string. Okay, so I get it. I get that. Okay, let's try matching on what was it called? Code env. Okay, code env. Backend type with What's the backend type? Cuda device, Cuda host, Python. Okay. Okay, it is going to be what? Let's say it's line S abort. Abort. In fact, before we do that, let me just try it out. Um, Let me comment all this out. Do this. Yeah, now I just have this main, and suppose I did an abort. Abort execution and generate a core dump. Yeah, okay. Let me just try running this to see what happens. Yeah, it's... Okay, let's modify the build script a little. Pro program execution failed. So this isn't generating a code dump for some reason. What if I did? No, and that won't work. Print f so the suppose I did this. Okay, it's really bothering me that it's not generating an error status code when I call abort. Okay, in cases like these, we can just ask Perplexity, why is C++ abort not giving an invalid status code and running the program? So I need to maybe call exit. Okay, you learn something new every day. So yeah, instead of abort, we need exit, and then we just give it -1. All functions with that exit and on exit in the reverse to the order original registers. Perform studio cleanup. Okay, I guess this is good enough. Sake. Okay, why is the mail script not there? Yeah, let me see what happens if I run it directly. And this is in what the Q game Leduc. Okay, let's see. Not this game Leduc. Bin. We need to get a current terminal. What happens if I do this? Yeah, not even this gives an error status code, which is very weird. Wait, what? Why is the first time I do this? Why does it give false? Well, yeah, oh, all right. Fuck. The false does mean that something is wrong. Uh, I'm just being retarded. Let's see. If okay. So this is supposed to throw if it's. Let's try this again. But I actually didn't know that we can only check the status code once, and then it will get overridden. So if I do 0 here, that's fine. What about this? Execution failed. Okay, this is exactly what we want. So in the code generator, instead of using abort, we need to use exit. Okay, let's use exit -1. We're going to wait. On the device, we actually need to use the trap. In Python, I don't know. I mean, this is a Cuda code generator, so we don't have to compiler error. this. Uh, I don't have to handle Python. Yeah, that's that. So let's see. Okay, so we also have this. Okay, that's one thing fixed. Let's compile it. Where's it? This. So now we open the VS Code plugin. Control F5. We don't need this anymore. Instead, what exactly were we doing? I think it was this. Right, so repetitions with I think, yeah, now this has exit -1. Let's try building it. Not bad. It at least runs. Let's just open. Let's print it out as well. Mm, Zero length blue format string. King 62, King 31, King 62, King, Queen, Queen. Yeah. Okay, yeah, this works. Maybe we'll add this to the list of warnings so he suppresses it. But it isn't important right now. Maybe we could just omit it out in the library itself. Let's see, how would we get rid of that? Let's see, core extension. Is it here? Maybe. I mean, it's probably in core Cuda. Let's see, where is print? Oh, I actually forgot that we had a special op for this. Spiral language. Int f. Yeah, so it's like this. If args is empty, if let's see, d equals data format in if d is string is I meant to take a screenshot. God damn it, this is such a pain in the ass. Why am I even doing this? Then maybe we can just check that the printf. I know we cannot omit it. Yeah, because this is an operation. So I mean, maybe at worst, maybe we could try replacing it with a null or something like that. No, and no, it's not worth the bother to try to fix this. Forget it. Who cares? Let the C++ compiler complain. Fuck it. Okay, so that's one thing. Mm, yeah, so, let's see whether we can figure out why drawing the cards doesn't work either. Let's build this, and we'll probably get the same error. Yeah. In backend switch, I picked a record with a Cuda host field. Let's see, this is only in, yeah, conjoint CPP and conjoint Python. In the, in the Python, I'm just going to put in this error message to disambiguate them, but I'm pretty sure this is it. It's just, so, yeah, Cuda host, and this is the backend switch for the C++ backend. So it's not in the record. Okay, so it's not in the record. Okay, so it's not the draw card, so it has to be SA create or set. Okay, let's do it one by one. You know, when I do this, static array union tree. Okay, so that works. And if we try setting it to something, let's see, set array 0 ping. If we build this, it works. So is the problem the loop then? It certainly seems like the problem is the loop. Oh, that out. Okay, suppose I maybe replace this in with a I mean, suppose I replace the let with an in. Oh, okay, now it works. Interesting. So now that we see this error, I'm kind of leaning towards this being a problem in the partial evaluator. Jack, king, queen, 26. King, queen, jack. Queen, queen, king. Jack, jack, queen. Okay, let's bring back the let real file. We're going to check out the partial evaluator. I think maybe it's substituting the Cuda host with the Cuda device somewhere. Let's see. Spare language. Let's go into the partial evaluator. And it's not like I myself remember all this. It's just that it's well organized, even though it might not necessarily seem that way. Okay, where's the backend? Backend. So what I need to do is figure out all the places this gets accessed. Find all references. Yes, backend. Also correct. Is backend. Is backend. Like join point. Process strings. It's just a list of all the backends for some reason. So this is the the join point handler on the term side. So the error should be here, I think. No, wait, no, this has to be wrong. Like, backend switch expected a record. So, no, the problem has to be in backend switch. It cannot be. Let's take a look at. No. It cannot be a loop. It has to be. What the hell is wrong? Okay, I guess we could try printing out like the expression. It's very weird. I mean, the users cannot do this, but I can. It's kind of like last ditch. CPP, switch. What was there? No, wait, this is parent language. Go here in backend. Backend record. CPP backend switch. Wait, oh, this is a type in my macro. Ah, so in let it's probably trying to generate a type and it doesn't have it. All right, right. I see. In the CPP type, the Python type backend switch. Yeah, I thought this was some kind of term level backend switch, but this is just for printing out the types. Okay, so I was completely wrong. Let's let's also just also build this again. Yeah, I don't want to press Control F5 on. I mean, Control 5 on the PowerShell script. Let me just open this. It's kind of not a good habit to try running the publishing script, even though Control 5 won't run it. So okay, we have the let, and it's probably oh, let me think. It's probably dragging one of these. Yeah, it's probably RNG or the deck. Let's see. What is the deck? Or maybe it's just the static array that it's dragging in. We'll try it out one by one. So let's see. Let's make a join point. Join, and we have the deck, and we have the RNG. So if we try building this, okay, so that wasn't the problem. Then what exactly is the problem? Is it maybe the static array? Yeah, it's a static array. Yeah, but let's see the array. In CPP type backend switch, expect a record with the Cuda host field. Yeah, nice. Okay, let's check out the static array. We can close that. Yeah, we need the type itself. Yeah, we should also fill in these cases. I'm not gonna say we simply made a mistake using Python and trying out all those algorithms. let's say list let's also Python is amazing. First, I make a mistake of not using it, and then I make a mistake of using it. You know, we go in base, and let's see, where is this defined here, like this. Then we also just have to add Cuda host case. Okay, so it recognizes it. So list. Host. Uh, let me do this. Do this. Do this. Also turn that into Cuda host. And why is this not giving me an error? Do this. Yeah, now it gives me an error here. But if I do this, why is this not giving me an error? Oh yeah, because now if I do this, yeah, now it's fine. Okay, good. And so now we have these backend switch types mirrored. Okay, let's try running this again. Build file. Let's try running this. Not bad. Let's build the entire thing. Mutable struct. You know, maybe we could replace these structs with the inbuilt C++ ones. I'm gonna try drawing 6 cards just to see what would happen. Not 7, but 6. Suppose I draw this. King, king, queen, queen, jack. Let's see what happens if I try 7. And that should probably abort the program. The program execution failed. Really? Why did it fail? I mean, shouldn't there be some kind of error? I have to see some kind of error being printed. Draw cards. U32 to card. Sample mask bit. It's probably, the problem is probably in U32 to card. Let's see. Invalid int in int to card. I'm guessing this is what should get printed. And the reason why it's not getting printed is if you look in the where's the build script? Yeah, because we have this d equals n debug, and that is suppressing the asserts. So what do we do here? You know, I really want to just uncomment it like this, but then, yeah, the script will start working. That's so annoying. What exactly do we do? I'm sure we can just pass the arguments as they are. This isn't such a bad time to maybe, yeah, to see how extra args can be, could be just extra args. Let's make this an array. And we could put in an include as an extra argument. So what exactly would this do? If I try, I'm not, I don't think I have to compile this anymore. Just for now. Let's also comment this out. And if I do write post extra args, what I want to see is it's kind of it tries to interpret it as a command that dash I. Okay, not bad. What would happen if I, for example, did like let's move this here and then just do extra arcs. I think this probably won't work. It really does. It really did work. Yeah, maybe I could just, in that case, includes. But I could probably just do cpp libs and then yeah, I could probably maybe I could splice it in like this. Includes. I mean, I vaguely remember that in PowerShell when you splice other arrays into arrays, it kind of puts them in like this. Yeah, And then it's kind of. I remember that actually making nested arrays in PowerShell was tricky. I forgot what the trick to it was. It's been a while. Don't know what to do. Right, host, external args. Let's see. But if I do this, maybe it is saying that it actually works. This does still compile. Wait, what the hell? Yeah, I did something weird here. Like it did work earlier. Oh wait, I'm trying to. I'm such an idiot. I'm running it on the script file itself. What the fuck? That's what happens when you turn off your brain. Extra args. And now let's do the includes again. Now if I try building this, if I comment this out, this is pretty much the main reason why I decided to put it in an array. I mean, it builds, but it doesn't give us an error. Yeah, let me just do. Let me just put in a print statement so I can be sure that this is in fact the problem. So right, and then Steve. Now let's build. The game has an error for ext build. Wait, it is just building it, and it's not running it. Sorry about that. I forgot that I commented this out. Um, maybe it's maybe it's trying to set the array at yeah, maybe the error isn't necessarily here. but in something like SA set, let's see. This is index and set. It's not really checking that the index is in range. Let's try building this, and then Ctrl Shift V. Okay, let me try adding this option. V format zero length. The build script. That's one way of verifying whether these extra arguments are actually doing anything. And an option. We need to do we know instead of. See, and an option we know format zero length. We put it like here directly. Yeah, I mean, is the same problem? Yeah, maybe this isn't an option for NVCC, but it needs to be passed to GCC. Do when compiling program with NVCC, how do I disable the compiler? Oh, so that's how it is. Right, so I need to separate them with commas. How do I separate them with commas? How do I separate them? Oh, so like this. Oh, okay, this is very instructive. Okay, X compiler equals. I mean, we can just probably do this. then like this, maybe would this work? I wonder. Okay, let's give it a try. Great, and this really does work. And I could also maybe separate this out, like the and debug. Let me comment this out. I'm going to remove this I from here, and then includes. How do I map this array so it appends in PowerShell? How do I map an array strings so it prepends I to them? Reach object. Hmm. Okay, yeah, this is a pretty good solution, I think. Let's give it a try. Okay, wait, I'm starting to run the script again on this. But yeah, it does. It prepends the I to that string, which is very nice. Okay, can I maybe do like? Can I maybe do it like this? Can I do Can I do it like this? And this is how I would write it in something like Spiral or F sharp. Oh yeah. Okay. Oh, nice. I think I could probably just do this cpp and libs. Yeah, that will simplify it a little. Cpp libs includes. Let's put a comment. This is so it doesn't give warnings on things of certs. Okay, so this is very nice. You can okay. I mean, maybe if you're in a hurry to make $1 million, this won't be a big deal. But it's an enjoyable part of programming to get this into shape. Of course, now we have these extra arguments. And it's kind of better. Now we have some written here, some in here, but it's fine. It's fine. We have to figure out why nothing is getting printed when we, for example, try indexing out of range. Okay, let me comment this out. I'm going to create an array again. Then I'm going to try set it. Set out 5 king. Okay, how about that? That's nice and easy. Index was being set. Okay, so it kind of catches it at compile time because this is a constant. But if I do bin, it will compile it, and then if I run it, will the assert actually trigger? Well, it will exit the program, but yeah, it prints the assertion here, right? Assertion index must be range in set. Wait, did that? Yeah, that didn't happen last time, so that's not the problem. I have to know why this is not happening. So, right, Ellen. Let's print out the card and the deck. Build. Did we? Jack, King, Queen, and then there's an exception. Let me just remove this print statement from here. Now generates the line info and system device. There's on the optimizations. Optimizations allows relaxed constant. Wait, is it a Cutlass specific hack? It's been so long. These warnings. I'm not sure this is a Cutlass specific hack. Files selected C++ standard. Output. That's no. And, oh crap. And maybe these comments will actually end up breaking everything. Ah, fuck. so we cannot put in the comments. Yeah, this is actually a good reason to actually put in main args. I'm going to put all of these like here. Cuda. Right. Actually, it's not just the line info, but also the symbol info on host. Constant expressions. Warnings. And as I said, the only reason why I'm actually doing this right now is so I can put in these comments, so we can actually know what these various options are, even though some of these aren't that great. Um, yeah. I mean, but, now that we have this, it's not like there's any difference between args and extra args. So we can just put in this here, and this here. This could also be done like this. Like this. Yeah, we don't have this anymore. And we can just rename this to BCC arcs. And we can just put in path at the end here. Input file. Let me try building this again. Yeah, the whole program builds without issue. And this is very new to me. I actually didn't know that it was possible to just pass in arrays like this. And it's very nice that this actually ends up concatenating the array to the enclosing one. I think there's also a way to somehow make it so that it doesn't concatenate the arrays, but I forgot how that was done. I asked Perplexity about it at some point. Um, maybe it's you simply need to do it like this or something like this, and maybe it won't concatenate them if I do that. No, even that wasn't it. Oh, whatever. It doesn't matter at all right now. Um, let's focus on the task at hand, which is figuring out why nothing is getting printed. So we have the print statements here. The card has been set. Stay building this. Ctrl Shift V. The card has been set. Okay, let's do drawing card. Build. Shift V. So it tries drawing a card, then it dies. Deck. Random U32 U bound. Yeah, let's print out console right Ellen. And then we'll print out the base. Build. Base equals 0. Drawing a card. King. So it never gets to actually draw the. See, it never gets to actually draw the base. So the problem is probably here. Let's see what this U32 U bound. Let's see where it is. No wait, what the hell am I doing? U32 U bound. And the range should be 0. So we need to assert let's do this. Assert zero range. The range has to be greater than 0. Suppose we do this, build file, then Ctrl-Shift-V. Yeah, now this assertion gets triggered. Yeah, perfect. I'm very happy with this. If we maybe, for example, turn off the asserts, let's see, where is that? Where is the? Oh my god, did I accidentally maybe remove it? Yeah, the and debug. I think I turns off the asserts. Suppresses. So I probably removed this by accident at some point. Okay, so let's try building this again. Yeah, now the asserts aren't actually getting printed anymore. So let's comment this out. We're also going to remove the print statements that we've sprinkled throughout the code base. And yeah, that's not really the point of this test. I was just curious what the problem was. Yeah, nice. And yeah, if you think about what we accomplished this morning, that would be to pretty much translate everything in this module, so it works on the host. And after that, what we'll do is work on the rest of the game. And I don't think that will actually be that difficult because, in fact, this random sampling was one of the trickier parts, since it's not the same between the host and the device. The other parts I think will be easier, but what will be a bit tricky is that we'll have to implement the counterfactual regret algorithm after we've done translating the game. Done converting the backend module to the host side. I'm going to publish a new spiral version. Let's see. Fixed the erroneous exits on fix the erroneous panics in the Cuda host generator. Let's see, where is the changelog? Also, let me just publish this. Copy. Wait. I need to publish it in pre-release. Um, re-release. What the hell? Is it upgrading it again? We want to open the credential store. VSC. Okay, so it's out on both marketplaces. Okay, let me commit this. And yeah, that's about it. So let's finish this video here, and we'll continue working on Leduc in the next session. I'll see you in a few hours. Bye bye.